In taxicab geometry, there's basically no such thing as a diagonal. If you want to connect 2 points, the only way to do it is by actually traveling along the grid lines. And that's why it's called taxicab geometry, because you have to travel on the streets, and usually streets are set up in a grid pattern. So you could go that way, or something like that. There's lots of different paths you could take, but the shortest distance, no matter what, will be the same, and that'll be a length of 6. Here we go 2 and then 1, 2 and then 1 is 6, or 4 then 2, or 2 units then 4 units. Either way, it's 6 units. Another thing you can talk about is we can translate the idea of a circle, which is all the points that are the same distance. So let's look at a circle with center 0, 0. And pick a radius of 4. So you could go 4 units to the right, 4 units up, 4 units left or down. You could also go 1 and 3, or 3 and 1, or 2 and 2, or 3 to the right and up 1, or 2 to the right up 2, 1 to the right and up 3, or same thing on the left. So the idea of a circle in taxicab geometry is actually more like a diamond or a square. So I already hinted at distance in taxicab geometry, but let's go ahead and write it out formally. Between any 2 points, x1, y1, and x2, y2. We know that in Euclidean geometry, it would be x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root. But that's because you're allowed to do diagonals. In taxicab geometry, you can't do diagonals, so you're looking at your distance along the x-axis and your distance along the y-axis, and you add those together. So distance along the x-axis is the difference in your x-coordinates and its absolute value. And same thing for the y. Your distance along the y-axis would be y2 minus y1, absolute value. And you have to add those two distances together. This is the distance formula for taxicab geometry. So you might see a problem that looks something like, that says, find all the points that are equidistant from some given points. So let's take a look at from the 2 points 0, 0 and 1, 3. So here's 0, 0, and 1, 3. There's 2 points. We're looking for points that are equidistant from both of those. So some point x, y that's equidistant from those two. So, for example, if we go from 0, 0, 2 to the right and up 1, that's a distance of 3. And from our point 1, 3, that's down 2 over 1, that's also a distance of 3. So the point 2, 1 will be a solution. To find all of the points, though, we're going to have to use the formula. And we're going to need the distances to be equal. So if we are using the point x, y, plug in x and y for our solution points, but we'd have to subtract our points, our given points. So our distance from 0, 0 will be x minus 0 plus y minus 0. Our distance from 1, 3 would be x minus 1, y minus 3. So we'd be looking for when these distances are the same. So when absolute value of x plus the absolute value of y is equal to the absolute value of x minus 1 plus the absolute value of y minus 3. So one of the things from these equations that you might be able to see is that if x is greater than 1, then the absolute value signs don't matter. You can get rid of them. We would also need y to be greater than 3 to get rid of them completely. Let's just look at x greater than 1 for right now. So if we work on solving this, if x is greater than 1, tells us something about it. We can't just solve this outright, but if we go back to where we started, with the points, we can also look adjacent to the point that we found right away. That's down 2 and right 1 up 1. So that point right there, 1, 1, is also equidistant. Check if we just go to the right. That'll be 1, 2, 3, distance of 4, and down 2 over 2 is a distance of 4. That's good. Since we just continue moving to the right 1 each time, that's only adding 1 to the distance. So all of these points are equidistant from both. Also, we could do the same thing on the left side. Straight up is a distance of 2, so is down 1, left 1, distance of 2. If we move to the left, that makes the distance from each be 3, again makes it distance 4, and so on. So all of these points are equidistant. From the given 2 points.